So what exactly is RAG? Think of a standard LLM like ChatGPT as a brilliant student who has read an enormous library of books but is now locked in a room to take a closed book exam. It can only answer based on what it remembers. If its memory is flawed or outdated, its answers will be too. Now, imagine giving that same student an open book exam. Before answering a question, they can go to a specific curated bookshelf and find the exact right pages with the relevant facts and then use their intelligence to formulate a perfect answer based on those facts. That's RAG. RAG is the process of giving a large language model access to external, up-to-date information before it generates a response. It combines two powerful abilities. The retriever. This is like a super fast, hyper-intelligent librarian. Its only job is to find the most relevant pieces of information from a specific knowledge base. And the generator. This is the large language model itself, the brilliant student. It takes the user's question and the information provided by the retriever and synthesizes a coherent, fact-based answer. Is the best of both worlds. The vast reasoning power of a large language model combined with the accuracy of a targeted factual database. Okay, so how does this magic happen behind the scenes? It's a two-part process. First, we have to prepare the knowledge, and second, we have the live question and answer flow. Indexing. Preparing the knowledge library. Before you can ask any questions, you need to build your special bookshelf. This is called indexing. Let's say you want to build a chatbot that can answer any question about the Harry Potter books. First, you gather all your documents. In this case, all 7 Harry Potter books. This is your knowledge base. Chunking. Reading all 7 books for every single question would be incredibly inefficient. So you break them down into smaller, manageable pieces or chunks. Think of this as tearing the book into individual paragraphs or pages. Embeddings. Now for the truly cool part. You can't just store these texts into chunks in regular folders. A computer needs to understand the meaning of the text. So you use a special AI model called an embedding model. This model reads each chunk of text and converts its semantic meaning into a list of numbers called a vector. Think of these vectors as a unique GPS coordinate for the meaning of that chunk in a vast multi-dimensional space of ideas. Vector database. Finally, you store all these vectors in a special kind of database. This isn't your grandma's filing cabinet organized alphabetically. This is a library where all the chunks are organized by their meaning. Chunks about Quidditch rules will be clustered together, while chunks about Voldemort's history will be in a different neighborhood. And that's it. Your knowledge is now indexed and ready. Now, the system is live. A user come along and ask a question. What are the 3 unforgivable curses? First, the user's question is also converted into a vector using the same embedding model. It gets its own meaning coordinate. The retriever takes this question vector and goes to the vector database. It performs a similarity search, looking for the text chunks whose vectors are closest to the question's vector. In our example, it instantly finds the paragraphs from the books that explicitly describe the killing curse, the Cruciatus curse, and the Imperious curse. The system then takes the original question and these retrieved chunks of text and bundles them together into a new enhanced prompt for the large language model. Finally, the generator, which is the LLM, it receives this prompt. Instead of answering from memory, it reads the provided text and formulates the answer. The 3 unforgivable curses are Avada Kedavra, the killing curse, the Cruciatus curse, which inflicts unbearable pain, and the Imperious curse, which gives the user total control over their vector. Crucially, it can also provide the source pointing back to the exact book and page it got the information from. No more guessing, no more making things up, just facts. So why is everyone so excited about this? It massively reduces hallucinations because the AI is grounded in specific facts. It's far less likely to invent information. It provides up-to-date information. You can constantly update your vector database with new articles, reports, or data without ever having to retrain the entire multi-billion parameter model. It creates trust and transparency. Modern RAG systems can can show you their sources so you can verify the information for yourself. This is huge for enterprise and academic use. It's cost effective. Fine-tuning a massive large language model can cost a fortune. Building and uploading a vector database is far cheaper and faster. What's the latest? The cutting edge of RAG. RAG is evolving at lightning speed. What I just described is the basic version. The latest advancements are mind-blowing. First, we have self-corrective RAG. This is where the AI double-checks its own work. It retrieves some documents and then uses the LLM to critique them. Are these sources relevant? Are they contradictory? It refines its own search results before generating the final answer, acting as its own internal fact checker. Next is adaptive RAG or ARAG. The system is smart enough to know when it doesn't need to search. If you ask it a simple question like what is 2 plus 2, it won't waste time searching its database. But if you ask it what were our company's sales figures for the last quarter, it knows it needs to retrieve that specific information. It adapts its strategy based on the query. And perhaps the most powerful new development is graph RAG. Instead of just storing chunks of text, this approach uses knowledge graphs. It understands the relationships between things, that Harry Potter is a student at Hogwarts and fights against Voldemort. By retrieving information from these structured graphs, the AI can answer much more complex questions that require understanding relationships and synthesizing information from multiple sources. RAG is more than just a clever trick. It's a fundamental shift in how we build and interact with artificial intelligence. It's the bridge between the incredible reasoning power of large language models and the messy, ever-changing, fact-based reality of our world. We are moving away from the all-knowing black box model of AI and towards a future of transparent, verifiable, and continuously learning systems. The creators and the companies who master RAG will be the ones who build the most trustworthy and capable AI applications of tomorrow. The future of AI isn't just a bigger brain, it's a brain with a library card. Thanks for watching. If this blew your mind, hit that subscribe button and let me know in the comments what you would build with a RAG system. See you in the next one.